Okay, this is number 6 from chapter 14.3, and this is definitely a doozy. It kind of takes you through the full process of developing a linear model with multiple explanatory variables. So we've got all these, and this is, the situation that we usually have, when you collect data, you honestly often have too much data, right? And you don't know whether those variables, will contribute to, a prediction model or not. So the first thing we do is we construct a correlation matrix for the different variables, and we're looking to see if any of these, right, if like x4 and x1 correlate to a high level. And it looks like the highest one is x4 to x2, but it's not high enough to really trouble us. So we don't have a multi-collinearity problem because none of the variables, the explanatory variables, are extremely strongly correlated. Okay, that doesn't mean that we're not going to throw out some of these variables, but that's kind of the first test. So what they wanted us to do is, after that, is determine if we're going to do a hypothesis test to see if any of the slopes are zero for any of the explanatory variables. And we didn't get any zeros for any of the variables. And sorry, here's where we just constructed the regression line, right? This is what StatCrunch gave us. Here's where we're going to test the hypothesis test for whether all the slopes are zero or not, okay? And because we got such a small p-value, we conclude that at least one of the variables doesn't have, or one of the coefficients isn't zero, one of the slopes isn't zero. So something's contributing to a prediction in this model. Okay, we don't know exactly what yet. Okay. Now, what we're going to do is test each coefficient individually and do a hypothesis test for each coefficient individually. And we're just going to iterate that for x1, x2, x3, and x4. So this is the slope of x1, right, to see if that's zero. And we get a p-value of 35. So that's really telling us that we can't, at a, what are we going for? What level of significance? At I think a 1% level of significance, we can't reject the null hypothesis that the slope for x1 is really zero. So we're going to end up throwing explanatory variable 1 out of our model because of this. Okay. So, and here we say not significantly different. Okay. Now it wants us to, of course, go and do this for all the other variables, x2, x3, and x4. And when we do this, when we do the hypothesis test for each one individually, we see x2 is significantly different. x3 is not significantly different from zero. So we're going to throw x3 out, and then x4 is significantly different. So what that tells us is we're going to develop our model, with x2 and x4. Okay, that doesn't mean that they're safe yet. There's more work that we have to do. These problems are doozies. I think there's like 16 parts to it. Okay, so when we redo the regression model, leaving out x1, so this is just leaving out x1. This is with x3. In a second, we'll do it without x1 or x3. So this is the regression, right, model without those two explanatory variables, just with x2 and x4. Now, of course, just like in the other problems, we have to check the residuals and make sure there's no kind of significant pattern for the two variables that we have left, right? So this is the first one is for the residuals versus the fitted values. This is the residuals versus x2 and the residuals versus x4. And none of them really, when you look at the graphs, observe it kind of a pattern that would trouble us. And we also have to do a box plot of the residuals and make sure there's no outliers, right? And this is the box plot we get for the residuals. Okay. Now this is the part that the student really asked the question on. Once you have this model, how do you do the prediction predict a particular value. Well, you're just going to really stick x2 and x4 into the prediction model that we developed, the prediction equation that we developed up here. And we also have to get confidence intervals and a prediction interval. And that's not as easy. It's not as seamless as it is StatCrunch. It's a little easier when it's just a simple linear regression model in StatCrunch. When it's multilinear, we've got to trick it into giving us these things. So what I'm really going to do is just enter these values that we're interested in getting a prediction for: 36, 37.4, 17.1, and 26 right here. Okay. Notice that has no y. This isn't an actual data point because it has no y. And I'm going to rerun the regression model with y. And again, I'm not doing explanatory variables 1 or 3, just 2 and 4. Okay. And this is where we're going to get the stuff that we want. So under save, I'm going to do predicted values. That's going to get me the answer to this question, the prediction. And I'm also, you'll see later, we're going to want a confidence interval and a prediction interval. So this gives me the confidence interval. Whoops, didn't mean to click that. Yeah, predicted values, confidence interval, and prediction interval. And I compute these. What's going to happen is you see that now my data has more columns, right? My spreadsheet here has more columns. These are the predicted values of all of this stuff. And these are the upper and lower limits of for the confidence intervals around each of the points, okay? And then the second one is the prediction interval, right? Let's see. Sometimes I forget which one's which. And yeah, so this is the mean, right? So that's the confidence interval. These are going to be the prediction intervals, the second two. Limit, yeah, the lower limit individual at the prediction interval. Okay, so that's where you see this in this column or this row that I created. The prediction is 97.96 when rounded to 2 decimal places. And now to construct a confidence interval, I just put this into 2 places, 248.18 and 267.74. I check it. That ends up being right. Remember what that means, right? That's if we did this experiment and we put these values in a number of times, and observed what the y would be, that's saying that the average is expected to be this value and be between these two 95% of the time. We're going to capture this value, the actual value inside this interval, whatever the observed value is. Okay. Now, of course, when we do the prediction for the individual reading, right? If we just do it once off, the standard deviation is much greater. So it's gonna have a wider confidence interval because the standard deviation is greater. Oops, 227.87, and then 288.05. And so those are the trickiest parts of this problem. It's just that it's not, on the simple linear regression, you just hit StatCrunch. There's that little place to put the prediction in, and it gives you the prediction intervals and the confidence interval, and you're done. But here you actually have to enter in the data just omitting the y, right? You don't know what the y is. You just want a predicted value for it. So I hope that helps a little bit on this very long and tricky problem.